Recently, I've noticed a growing interest in retro-style digital cameras online. People seem to love the nostalgic look, the imperfect photos, and the feeling of carrying a dedicated camera again. And that made me wonder, could I build my own retro camera using my engineering skills and an ESP32? Well, 4 months later, this happened. Before I tell you how I built it, let me show you what it can do. This camera can record videos with sound, capture HD photos, play them back directly on the device, and transfer files over Wi-Fi. It has a complete menu system, a gallery, a time-lapse mode, a slideshow mode, camera settings, and a Wi-Fi transfer mode. And all of that runs on a tiny ESP32 board. Hello everyone. Today I want to show you my latest side project. This is an ESP32 based retro camera built around a Seed Studio Shao ESP32 S3 Sense and a 2-inch TFT display with a resolution of 320 by 240 pixels. I was inspired by Kodak's Charmera cameras when I started this project. At first, I thought it would be a fun weekend project, but I was very wrong. It ended up taking almost 4 months to finish. But the result was much better than I originally imagined. The camera can record MJPEG videos with sound at a resolution of 480 by 320 pixels and around 10 frames per second. The videos are saved as AVI files, which means they can be played easily using Windows Media Player, VLC, and most other video players. It can also capture HD photos at a resolution of 1280 by 720 pixels. One of my favorite things about this project is that you can view your photos and videos directly on the camera itself. There is something surprisingly fun about carrying this camera around and taking random photos while wandering around with friends. This project was also an experiment for me. I wanted to see how far I could push generative AI in an embedded systems project. I used Cloud Opus as my coding partner throughout the development process. Before writing any code, I collected my ideas, researched the technical details, and divided the entire project into roughly 20 development phases. This made it much easier to track the progress and focus on one problem at a time. But surprisingly, the software wasn't the hardest part of this project. The hardest part was turning the prototype into something that actually looked like a real product. While developing the software, I was also trying to design a 3D printed enclosure. The problem was, I had absolutely no experience with 3D modeling. So, I started learning Onshape. I mostly chose it because it runs on the browser, and I didn't feel like installing another large program on my laptop, which had very little memory left. I started with very simple things: small holes, mounting points, button placements, screen cutouts, the usual beginner stuff. Eventually, I designed several parts of the enclosure myself, but fitting everything around the shower board turned out to be much harder than I expected. Things like the SD card slot, camera position, antenna area, battery placement, and USB-C connector all had to fit inside a very small space. After spending a lot of time experimenting, I decided to use some existing open source models created by other makers. I found an enclosure design that perfectly matched my needs. It provided easy access to the SD card, the USB-C port, and the antenna area, which were all important for this project. I also found a clever shutter button design and a rotary encoder knob design that matched the overall look of the camera. Using these community-made models allowed me to focus on the parts that were unique to my project, and eventually, the enclosure was finished. This part of the project consumed the most time, effort, failed prints, and filaments. But holding the finished camera in my hands for the first time made all of it worth it. And honestly, one of my favorite things about projects like this is the open source community behind them. A model they uploaded years ago can become an important part of something you're building today. I think that's pretty awesome. Now, it was finally time to put everything together. I installed brass heatset inserts into the enclosure using a soldering iron. Then I grabbed a piece of perf board and started soldering. The LEDs, rotary encoder, shutter button, battery connector, everything eventually found its place inside the enclosure. Please don't judge my soldering skills too harshly. A lot of glue was also involved during this stage. After connecting all the wires, it was finally time for the moment of truth. Would it actually work? Luckily, it did. Seeing the fully assembled camera turn on for the first time was genuinely one of the most satisfying moments of the entire project. Originally, I wanted to bring this camera with me to the Ye concert in Istanbul and try to recreate this masterpiece. But I eventually decided against it. I was afraid of dropping, breaking, or losing it somewhere in the crowd. Instead, I started carrying it with me when hanging out with friends. And honestly, their reactions made all the effort worth it. People were especially surprised by the retro look of the OV2640 camera sensor, the blue-green enclosure, and the fact that photos and videos could be viewed directly on the device. But of course, not everything went perfectly. The biggest disappointment was the Wi-Fi transfer mode. The software itself works. I tested it successfully on another shower board, but unfortunately, the board inside the camera appears to have some kind of physical damage, so the Wi-Fi functionality doesn't work reliably on this particular unit. That's the reality of hardware projects. Sometimes the software works perfectly, but a damaged board, a bad solder joint, or a tiny hardware issue can still ruin your day. There's also another issue I've noticed. When taking photos in bright sunlight, the image sometimes develops a strong green tint. Some of my friends actually think it makes the photos look even more retro, but it's still a bug, and I'm currently working on fixing it. By the time this video is published, there's a good chance the problem will already be solved. Overall, I'm really happy with how this project turned out. I learned a lot about embedded systems, FreeRTOS, 3D design, hardware prototyping, and even AI-assisted development. And most importantly, I ended up with a camera that is actually fun to use. I've published all of the source code, documentation, and 3D models on GitHub. So if you would like to build one yourself, feel free to check out the repository. The link is in the description. Thanks for watching.